Good morning, Barkley Brookers. I don't know which story you started with, so we're going to read Curiosity, the story of a Mars rover. This is, if you didn't read the other story first or watch the other story first, the genre is literary nonfiction. It's when you have a nonfiction book that tells you factual information, but it's written so that it sounds like a story. That's literary nonfiction. This one is written and illustrated by Markus Motum. This one almost won our Barkley Brooksicott medal a couple of years ago. And so this is the Mars rover. The actual, this guy is actually on Mars right now, collecting photos and samples and all kinds of stuff to send back so that we can learn as much as we can about Mars, the red planet. Curiosity, the story of a Mars rover by Markus Motum. Wherever you are in the world right now, I'm a very long way away. I'm not even on the same planet as you. I'm a Mars rover. A rover is a moving robot built to explore far-off places, places too far away or dangerous for humans to visit. How did I get here? Why was I sent? This is my story. There he is. Now, if you recall, my friends, most of us, I think all of us, but definitely most of us, have been to the SteamMaker lab with the Lego We Do kit, and we built a little rover, the little movable Milo, the space rover. That was our first project, I think, that we did this year. So this is another different type of rover, and we talked about how there are places that we can't get to that are too dangerous. Inside of volcanoes, way, way deep down in the ocean where the pressure is too great, we can't get there. Mars is one of those places. It's just too far, the distance to get there. It's too long of a journey, so we send rovers instead. We send robots, all different kinds. Humans have always wondered about Earth and its place in the universe. Although scientists have made great discoveries and explained some of the mysteries of space, the planets hold their secrets well. Many questions remain unanswered. Of these, one question intrigues humans above all others. Is there anybody else out there? Scientists decided that the best place to look for other life was on one of our closest neighboring planets, Mars, the red planet. In addition to being one of our two closest neighboring planets, Mars is the planet in our solar system that's the most similar to Earth. Scientists think that in the past, Mars may have had environments similar to the ones on Earth today. Mars is covered in red dust now, but there is evidence that millions of years ago, the planet may have had lakes, flowing rivers, even great oceans. Why does this matter? Because on Earth, water is a necessity for life. However, there is one problem. The trip to Mars in a spacecraft can be over, do you see this big number? So these are the thousands, those are the millions, 350 million miles long. That's 350 miles, a distance much, much farther than any human has ever traveled in space. Even with our modern technology, we don't have a practical way to get humans to Mars. The journey would take at least 6 months, or to get them back again. Humans have been able to explore closer to home. On July 20th, 1969, Apollo 11 landed on the moon. Astronaut Neil Armstrong took one famous step and became the first person to set foot there. For the few hours he and Buzz Aldrin walked on its surface, people could look up at the moon and know that someone might be looking back at them. Mars is about 200 times farther from Earth than the moon, a journey that is currently very difficult for humans to undertake. The red planet is also an inhospitable environment. Inhospitable means it's you can't live there. But what if it were possible to send an explorer who didn't need food, water, or oxygen? That's where I come in. No, not I, me. Remember, we're talking about the Mars rover, right? Curiosity. Scientists at NASA, the National Aeronautics and Space Administration, came up with the idea to send robots to Mars in humans' place. The robots would need to be able to move over rough terrain with all the equipment needed to collect data and samples. So the scientists began to design rovers like me. We're talking about the different designs. The project to build and design Mars rovers was, and still is, based at the Jet Propulsion Laboratory near Los Angeles, California. I needed to be larger and more advanced than any of the rovers NASA had built before. Previous successful rovers had taken photos of Mars, giving NASA never-before-seen images. Other missions were orbiters and flybys, flying around or past Mars to gather information without even landing on the planet. By 2007, 39 missions to the Red Planet had been launched, and over half had ended in failure. Some of those earlier missions had become lost in space, while others crashed into Mars, never to be heard from again. So there's a Jet Propulsion Laboratory in LA, out in California. The lab where I was built had to be kept as clean as possible. Everyone had to wear white coveralls, which were nicknamed bunny suits. These suits stopped dust and germs from spreading to me and my equipment. The team didn't want to think they had discovered tiny forms of life on Mars, only to realize that it was just Earth bacteria that I'd brought with me. So this is like air and kind of blasting off all the bacteria and germs from outside of the bunny suits, the white clean suits, because they didn't want to transfer, just like we're keeping our germs safe from everybody else, they didn't want to transfer their germs or any particles of dirt or dust or anything to the Mars rover before it went to Mars. Because then when it came back, they might say, oh my gosh, here's a bacteria, which is kind of like a life form, and then discover it didn't really come from Mars. It had traveled from Earth to Mars and back again. Entirely new technologies had to be invented for my mission. I needed to be able to carry a lot of equipment to test what I found on Mars, my own portable laboratory. To give the mission the best chance of being successful, years of testing were needed to make sure everything would work correctly for the first time. After all, if something were to go wrong on Mars, no one could come to fix me. NASA ran a competition for members of the public to choose a name for me. Some of the names considered were Adventure, Journey, Pursuit, Vision, and Wonder. The winning entry was submitted by Clara Ma. She was a 6th grader from Kansas. The name she picked for me was Curiosity. Schematic, a drawing of his design. And then I was ready to fly to Mars. It was best to launch eastward and close to the equator to get as much energy from Earth's spin as possible. This also meant it was safest to launch where the ocean was to the east, just in case something went wrong. So I had to be taken to Florida to begin my space mission. I boarded a carrier plane and flew from Los Angeles. Do you remember he's being built over here in Los Angeles, California? The ocean is to the west, and he needs to go where the ocean is to the east, which is where we are, to the Kennedy Space Center down here in Florida. The rocket that would take me into space was waiting for me in Florida. The Atlas V rocket is around 200 feet tall, the height of a 19-story building. It is almost all rocket fuel. This is because it needs to be powerful enough to launch whatever it is carrying, known as its payload, into space. The Atlas V is known as an expendable launch vehicle, which means its parts can be used only once. I was placed inside the nose cone at the very, very top. There's the nose cone. The cone is like a shield that protects the rest of the rocket as it breaks through Earth's atmosphere. So you're going to see this part's going to break off. The whole rocket's going to come apart when it launches into space. My launch date was chosen carefully so that I had the best chance at a successful launch and the shortest trip possible. Because planets orbit the sun at different speeds and distances, sometimes they are very far apart, and other times they are much closer together. Every few years, Earth and Mars are lined up so that they are relatively close, allowing missions to reach Mars more quickly and using less fuel. That fuel is very expensive, number one, and two, it's very heavy. So the heavier that fuel, the heavier the rocket, the harder it is to launch. So they needed to make sure they used as little fuel as they needed to so that it wouldn't be as expensive and as heavy. If we had missed this opportunity, the mission would have been delayed for years. So there's all the planets orbiting. Here's the sun here, and the planets are all orbiting at different times. That's the asteroid belt there. Pretty cool. Launch day, November 26th, 2011. Arrived. I was ready to fly to Mars. In the control room, the team ran through the final checks. At last, the rocket was ready for countdown. 5, 4, 3, 2, 1. Lift off! There's the thrusters. The first part of my journey was breaking through Earth's atmosphere and reaching space. Once Atlas V's various boosters had done their job of getting the rocket into space, they broke off and fell safely into the ocean. So here's the rockets all kind of coming apart and falling down into the ocean. And there's that nose cone piece. See? After 253 days hurtling through space, I finally arrived near Mars, traveling 13,000 miles per hour. Next would be the trickiest part of my entire journey, landing safely. 13,000 miles per hour. No rover or space mission had ever tried the type of landing I was programmed for. It would take 7 minutes from the time I penetrated the atmosphere around Mars until I landed on the surface. The team at NASA called it 7 minutes of terror. If I had been landing on Earth, the atmosphere would have slowed down my entry, but Mars has much less atmosphere than our home planet. So as soon as I entered the atmosphere, a huge parachute opened, slowing me to about 200 miles, 320 kilometers per hour. I was still moving too fast, so I dropped out of the back shell. For a few seconds, I was free falling to the ground. Suddenly, the powered descent vehicle, which was holding me, fired 8 rockets, slowing me down almost completely. And then I was ready to be lowered to the surface on cables, known as the sky crane maneuver. Once the descent vehicle detected slack in the cables, it knew I must be on the surface of Mars and released the cables. So here it is coming down. And then this is the descent vehicle. It's inside here. See it down here at the bottom? And then it lowers it on cables. And when it feels the cables slack, it means this guy's on the ground and it could let go of the cables and go away. I'm going to give you a little bit of a close-up there of that whole thing. I had made it. As soon as I was safely on the surface, I sent a message to my NASA team letting them know that I had landed. Because of the huge distance between Mars and Earth, the message took 15 minutes to get back to Earth. It was a tense time in the control room as everyone waited. Then the words everyone wanted to hear were read out. Touchdown confirmed. We're safe on Mars. And there's the Curiosity on Mars. It wasn't just the NASA team who had been watching my landing. All around the world, people tuned in to see if I had arrived safely after my long journey. Crowds gathered in New York's Times Square to watch on a giant screen. It was an exciting but scary time. After all, if just one thing had gone wrong, all contact between me and the team back on Earth would have been lost. When they'd heard I'd landed, some people cheered. Others breathed a huge sigh of relief. So that's the Jumbotron, straight in the back there, where people actually watch the ball drop on New Year's Eve. That's Times Square. And there's the Mars Rover. The next thing I did on Mars was send images of myself back to NASA to make sure I hadn't been damaged during the journey. My landing had been perfect, if a little dusty. The site had been carefully selected by scientists as a place likely to have evidence of water. Now it was time to start looking. Since 2012, I have been exploring Mars. The NASA team looks through my 17 cameras and chooses potential spots on the surface that may have evidence of life. Once something is identified, I move toward it. I can move more than 600 feet per day. 600 feet per day he moves, that's it. NASA also wants to understand how Mars was formed and how it was changed over time. The deeper I dig, the more information I can gather. I drill into rocks and scoop up material. I then test it in my onboard laboratory. Gradually, by piecing together information from different locations, NASA hopes to build a better picture of the planet's past and perhaps discover why Mars changed from being a warm planet with water to the cold, dry planet that it is today. So here's taking photos. That's its camera. And here are its arms, comes out. It can drill and scoop up material, and then the onboard laboratory is all inside here. Everything's all contained in here. There are many questions still to be answered. What was Mars like long ago? How suitable was it for life? Did it once support any life forms? The tests I carry out will provide as many answers as possible. Most likely, the discoveries I make will lead to more questions. With space exploration, questions can be just as exciting as answers. Thanks to the curiosity of explorers, Neil Armstrong's footprints are on the moon. And now my wheel tracks are being left on another planet. Perhaps one day soon, footprints from the next generation of explorers will leave their marks here as well. And this is just a quote by Clara Ma, the sixth grader who named the Curiosity rover. It says, "Curiosity is the passion that drives us through our everyday lives. We have become explorers and scientists with our need to ask questions and to wonder. We will never know everything there is to know, but with our burning curiosity, we have learned so much." All right, now, this book was written a few years ago. I think it was a 2017, yep, 2017. So, in that time, we've actually made some pretty cool discoveries on Mars, but I'm not going to tell you what they were. If you would like to know, if you have a burning curiosity to know what we now know about Mars that was different from 3 years ago, you can do that research. I do have a research assignment for you this week. It's pretty simple. You're going to go to the PebbleGo database. You're going to log in. The username is Barkley Brook, all one word, all lowercase, Barkley Brook, and the password is learn, again, all lowercase, learn. And you're going to navigate through the different topics in PebbleGo, and you're going to find the spot where you can find information about the planets. And I want you to do a little more research on Mars and find 5 interesting facts. They can be any facts that are interesting to you. Attached to this part of our Google Classroom is a Google form, and you're going to put in your 5 facts in those Google forms. If you want to share with the group, because the group's not going to be able to see your Google form, you can post in the comments one really, really cool thing that you found out about Mars in the comment section, and that way all of your classmates will be able to see some part of your interesting research that you did on Mars. You guys are all going to kind of be doing the same thing. At the end of the little segment on Mars in the PebbleGo database, there is another literary nonfiction piece called Seeing Red, and it's another book about Mars. You can explore that one if you'd like. That's your choice. I know some of you guys really, really love learning about planets and space. Some of you might not know that you love that yet, but maybe after today you will discover a new passion for outer space. But one of the cool things to do with that PebbleGo database is just to do a free explore. There's so much cool stuff in there. There's extreme weather, there's cultures, there's countries, there's animals, there's all kinds of cool stuff in there that you can learn about. Well, good morning, little man. Do you want to come say good morning? Yeah. Come on. Brody just wandered downstairs. Say good morning, everyone. Good morning. Brody and I read the Curiosity book, right? Did we read about this guy? We read him the other day. I just shared it with my second graders. Okay, so you got some research work to do this week, my friends. You also can continue practicing your typing. I will again post our top typers on Friday. You guys totally blew me away with your numbers this week. So I know some of you are loving that typing and you get to practice a lot. Some of you are sharing your devices with brothers or sisters and even with mom and dad who are working from home, so you might not get as much time to practice your typing as your classmates. But don't worry, any practice is good practice. And I miss you like crazy cakes, and I will hopefully see you guys soon. Keep yourselves well, keep yourselves healthy, and make sure you go outside as much as you can. Even if it's raining, guys, get bundled up, put on your hats, put on your boots, and go outside. We like to go for worm walks, right? We go and we explore, we see what we can see. You can see some cool stuff in the rain that you don't see when it's not raining and wet outside. So go ahead and explore and get some outside time, but keep yourselves safe, keep yourselves healthy, keep yourselves well, and I will see you soon, hopefully. All right, goodbye, my friends.